Hi everybody. Today we're talking about matplotlib, which is a library in Python which enables you to make beautiful graphs and plots of your data. So when you're downloaded your data, often you would like to plot your data as line plots or histograms or scatter plots. And in this gallery, this matplotlib.org gallery, you can find a lot more examples than you can find in this tiny lecture. And a very good tutorial is made by Nicholas, Mike, and Gael, and you can find that here at scipylectures.org. So let's get to it. So what you need to install to get a hold of the functions that we are going to use today is you have to import the matplotlib.pyplot as plt, because then we can just write plt dot and access whatever functions are in the pyplot library. So we import this alongside with NumPy, as we did in the last video. And this NumPy library will help us to make some data which we want to plot. So we have imported these libraries. So now we can make our sample data. And X is here just a linear space from 0 to 10, and we make 50 data points. So this linspace function is found in the NumPy library. And then we just make two other sequences of numbers, y and z, and this is the y is the sine of x and the z is the cosine of x. So now we have some data to work with. And the most basic way to create a plot is by the subplots function in matplotlib. So we write plt dot, because we imported matplotlib.pyplot as plt. So now we run this code, and we are going to have one figure object here and one axis object. And this axis object has a method called plot, which is a function. And here into this plot function, we pass in x and y. So our data values for x and y. And then to get this this plot to show, we have to call the plt.show function. So if we run this, we see that we have the figure here, and we have the axis around it, and we have our line plot. And our plot in this case is this blue line. But this blue line can be changed, so we can add some color and line style. So we can pass in this axis.plot function. We can add we can pass in the data x and y, and we can pass in a string, which is the color. B stands for blue and dash stands for line. So if we run this, we see that our line here is perfectly blue. So if we want to change the color to red, then we just pass in R, And if we want this line, this continuous line to be dashed, then we just do this. And this passing in of color and line style can actually be made more readable by passing these the color as color equals, line style equals, and marker equals. So in this case, we want the color to be blue, we want the line style to be a continuous line, and we would like to have a marker at every single data point. So here the marker is denoted by an O, so which makes for these large circles, and the marker can also be a dot, which makes for smaller circles, or it can be the caret, which makes for these triangles. For example, we also have the star. But let's just keep the circle. And so in this case, you explicitly know what the color is, and you know what the line style is, and you know what the marker is. So, and if you want to get a hold of the line formatting, you can look at matplotlib.org, the pyplot.plot page. So down here, quite far down, you will see the markers, and we chose the circle marker, but you see that you have a lot of marker options like plus or X filled. You also have a lot of line styles. So you have the solid line, the dashed line, and dashed dot line, and dotted line style. You also have a certain amount of preset colors, which are blue, green, red, and so on. But if we go back to our Jupyter notebook, the color can also be passed in as a hexadecimal value. And this hexadecimal value is a hashtag plus 6 characters. And these 6 characters stand for the red value, the green value, and the blue value. Which means that how much of the values should you, or the different colors, the 3 different colors, should you have in this color palette. And these hexadecimal values, they enable you to pick almost any color that you want for your graph. So in this case, I don't remember exactly which color I chose, but this is apparently purple. So, and if you choose these to be exactly equal, you will get probably something gray. So, let's see if we can get our original color back, and we did. So in this case, you can choose whichever color your company or business has in their color palette. You can also change the size of the figure, because you see here that this size is a default size, but if we want to make it, for example, bigger, we can put that in the subplots function as an argument. So in this case, we just set the fig size equal to 10 by 6 and plot our x and y. So in this case, you see that if we just do this, F11 to make this bigger, you see that now the figure actually got bigger. So and this you can just adjust such that it's the perfect size for your use, either for your publication or your web application. And here, well, maybe I should say that, of course, this 10 is the width and the 6 is the height. So if we change this to 4, then we kind of shorten the height of the graph. But let's just put it at 6 again. Another thing that you can do is to change the line width of your graph. So in this case, we have the plt.subplots, and this is the axis, this is the figure, and we have x and y as our data, a blue continuous line, and we can set the line width at 8. So or something else, 2 maybe, because this is the double the width than the original default settings. So this is double the width, or we can make it even broader as we set line width to 4. You can also add a label to your line plot, because if you look at this graph, you really don't know what is this. Well, it does look like a sine function, but most of the times you do not just plot a sine function. And you can add this label in the plot function as an argument. So in this case, the label is equal to this string variable. So we just plot sine x, but if we only do this, nothing will show. So in order for this to show, we have to use the legend method of the axis object. And by default, this legend is put here in the lower left corner, but we could, for example, put it in the upper left corner or upper center if if I can write this in the American way. You have full control over the position of the label. You can also change the axis values. So in this case, you have increments of 0.25 on the axis, but you would like for there to be fewer points on this axis. You can do that with the axis method set y ticks. And in this case, we would like for there to be a sequence of 0, 0 and -1 and 1. So in this case, you could actually do this. You can pass in this as a just a sequence of numbers, and this would be fine. So in this case, you have 0, you have -1, 0, and 1. Okay, there, I got it right. So, and this is defined in this sequence. So in case you would like, for example, 0.5, we have to get the negative here, and we have 0.5 here, and now we have this negative 0.5 and plus 0.5. But if you would like to define the endpoints, in this case -1 and 1, and the number of tick marks, then you could use the NumPy method, linspace, which is linear space. So in this case, you would have 3. Sorry, you would have 3 points on the y-axis. But this you can easily change to, for example, 5, or you could change it to 9, and so on. So this is how you can change the axis. And to change the x-axis, you could set the x ticks. And you can also add labels to the x-axis and the y-axis, and for example, a title above the figure. And in this case, we can get rid of this because we are not talking about that. We add, for example, a label to the plot. So the plt.y label is given as this string. So pass in a string to the y label function in the plt package. And you do the same for the x label method, and you can add the title. So in this case, the title is sine and cosine functions. And in this case, we only have, of course, the sine function. But you can actually plot 2 series in one figure. So if you would like for cosine to be in your figure, you can easily add that just by adding a second call to the plot function. So in this case, you have the x values and the y values being the sine of the x values, and you have the x values and the z values being the cosine of the x values. And here you can plot these in the same figure, and we say that the sine is with a blue color and the cosine is with a red color. And both of these have a label, and the label should be at the lower left. So let's see if this works, and it does. So here the red graph is the cosine, and the blue graph is the sine. And here you can actually put several graphs in one figure, and in this case you have to use the subplots methods as previously, but you add 2 arguments. One which is the number of rows, and one which is the number of columns. So just think of this as a grid. So now you're making space for two graphs on top of each other. So you have two rows and one column. In this case, you have to specify which axis or which piece of the axis that you are working with. In this case, we are indexing our subplot as 0 or 1. So 0 being the top position in this two-row configuration, and 1 being the lower one. So in this case, we want the blue line in the top figure and the red line in the bottom figure, and they should have a line width of 2. And in this case, we just run this, and we see that we have the sine function in the top figure and the cosine figure, or cosine line in the bottom figure. But they are, or both these plots are in the same figure. So if you right click and save this image, then both will be saved as a, for example, PNG file. And they will be together like this. And here we can't really trust the reader to decipher which is the cosine and which is the sine function, or that these are indeed cosine and sine functions. We should add some labels. So in this case, we can just add a label to each plot call, and we can just make the label show by using the legend function. But we have to do this for each of the plots in this figure. So if we do this, we see that now we have deciphered or decided that this is the sine function and this is the cosine function. But we can also add titles. So here we just set a title for the graph or the plot in the 0th index, which is the first position here, the top position, and we set a title for the plot in the index number 1. Sorry about that. So if we run this, we see that now we have the title on top of each plot. But we also see that we have some tickers here on the x-axis, but we have that on the bottom plot as well. And if these two plots actually share an axis, then we can get rid of one of them, which is usually the one in the middle here. And if you want to if you want to get rid of these x-axis ticks here, then you can do that in the set function. So here in the set function, we just add x ticks equals the empty list. So if we do that, we just pass in an empty list instead of these numbers. And then the graph actually looks much better, or the figure looks much better. And we can also add some graphs to the side here. Then we have 1, 2, 3, and 4 plots. And they are indexed as row and column. So in this case, we have plt.subplots are given 2 rows and 2 columns. So now if we are going to make a plot, we have to define which part of the axis object are we going to change. In this case, we are changing row index 0, which is the top row, and the column index 0, which is the first column. And we plot x and y. We want that to be blue with a line, and the line width is 2, and the label is sign of x. So this is the line itself, but we want to do something more with the top left plot here, and we would like to set the title equal to sign of x, and we do not want any numbers on the x-axis. And we do basically the same for the axis plot in row index number 1, which is here, and column index number 0, which is here. And we plot the x values and the z values, and we make the line, the graph red with a line width of 2 and a label of cosine of x. And we set the title for this subplot to cosine of x. And if we want to define the plots at the first column, or the second column here, that would be index number 1, which is here. And the first row has index number 0. So here we are defining the plot to the upper right corner, the 0th index 0 row and the index 1 column. And we would just like to make it easy or simple, and we just plot x and the negative values of y. We make this blue as well, and we label it cosine of x, or actually it should be negative sine of x, and this should probably be negative cosine of x. So sorry about that, and we will always save our changes. And in this case, since this plot to the top right here is sharing the x-axis with the bottom plot, and it's sharing the y-axis with the leftmost plot here, then we get rid of the y tick markers and the x tick markers, and we plot. And the last plot here is the bottom right at index number 1, 1, and we plot the negative of the z variable, which is the cosine of the x variable, and with a line width of 2, the label is negative cosine of x, and we set the title of the plot as negative cosine of x. And we have the ticks, the y ticks set to the empty list, because this plot is sharing the y-axis with the leftmost plot here. Okay, so now we are ready to run this code. And here we see that we have defined the line as a dotted line. So here we have a dotted line. And we do the same for the negative cosine of x. So this is how you can put several plots into one figure. But after doing all this work, you would like to save your plot. And of course, I've shown you previously that you can just either copy the image and paste it into, for example, Word document, or you can click the Save Image As if you would like to just save it on your computer. But you can also just make the code save the figure for you. Then you use the plt.savefigure method, and you specify the name of the file. In this case, we just save the figure, the last calculated figure, as lineplot.png, and it's always a PNG file, and the DPI, it's the image resolution, is 300, and if bbox inches equals tight, then you remove white space around the image. So if we run this, then we have saved our figure, and if we just press F11 to get out of the full screen mode, then we see that we have the line plot here. So that's how you save your figures, but you also have other types of plots. For example, you can make a scatter plot, and in this case, let's make some values instead. We have some x values and we have some y values, and in this case you write the same here. You use the plt.subplots, but you do not use the plot method of the axis object. What you do is that you use the scatter method of the axis object. And this takes in some x values and some y values. And then, of course, to show your plot, you have to use the plt.show method. So in this case, we have plotted our 6 points here. And we can actually change the appearance of our plot by, for example, setting the marker, in this case, a circle. We can set the size of it, and we can set the color. So if we try this, we see that we have set our markers to these values. We can change this. For example, this was way too big, so we can change the size to 10 and the color to blue, for example. But I would like to have the large red dots instead. And of course, this scatter plot can be more tweaked by adding some labels And you can also set the axis range with the axis dot set x limits and set y limits, where you just pass in some limits, the lower limit and the upper limit, in a list. You can also use the set title method, and in this case we just name it title, and you can also change the font size. And now we want to change, or we want to save our figure. So in this case, we have a title, we have label on the y-axis, label on the x-axis, and if we feel that this x-axis limits, they are, for example, too wide, then we can, for example, put this to 6.5 at the upper limit and 0.5 at the lower limit. Then we should get rid of some white space. To compare different groups or different categories, you can use a bar plot. And then we use the bar function of the axis object. And in this case, we are just generating a small piece of data. We have H groups, which are strings with 4 elements here. And we have a list of respondents, which are numbers. So we just run the cell to generate our data. And to make a bar plot, you also use the plt.subplots method. And here in the axis, or with the axis object, you use the bar method. And then, of course, you have to specify the x-axis, which are the groups here, H groups, and the value on the y-axis. So, and then you have to specify the width of the bars in the bar chart. So if this is equal to 1, they are filling the whole space. So if you put it to 0.5, for example, then you actually have some space between these groups. And you can also change the figure by adding labels and specifying more arguments. And here we start with the plt.subplots. We get the figure object, we get the axis object, and we want to make a bar chart. So in this case, we have H groups, we have respondents, and we have the width of the bars. But now we have a face color, we have an edge color, and we have an alpha, which is the opacity of the bars, and we have a hatch, which is the pattern inside of these bars, I mean, not bars. And the label is with the set y label method of the axis object, and you can set the x label as a string, and of course you can use the set title to give the figure a title. And then we save this this plot. So if we run this, we see that now we have a red color. This is the face color. We have an edge color, which is black. This is the edge color. And we have an alpha of 0.5, which makes the colors here, they are halfway opaque. So they are halfway see-through. And of course, you have a pattern on the bars. And this can be quite useful if you have several categories within each category. So for example, within each age groups, you have men and women, for example, and others. Okay, so if you change this alpha to 1, then the color red is not see-through. If you change this to 0.1, then it's almost totally see-through. So if you change it to 0.5, then you get this color. And for an overview of all the parameters and possibilities in the bar function, just check this link here. And lastly, we can make some histograms, and then we use the hist function of the axis objects. And to make a histogram, we just generate some data and put them in x values. So x values is just a list of numbers. And here we use the plt.subplots method, and we use the hist method of the axis object. And in this case, we just pass in the values, and we have to specify the number of bins. We just put these numbers into 10 categories, and then we count how many are in this category. And we have the face color, which is red, and alpha equals 0.5. This is just the opacity of the bars. So this can, of course, be changed to, for example, blue. Well, that did not seem very blue. It's probably because the opacity, yes, it was 0.5, and we changed this to red again. If you increase the number of bins, you just make it more fine coarse. So for example, with 40 bins, you have these bars, but in the bins between these integers, because we just specified integers, there are no occurrences. So in this case, quite few bins would be perfectly fine, because we only have integers between 1 and 9. And the height of these bars in the histogram, they are the number of occurrences of that number in this this list, which is passed in. So in this list, we have 1, 0, which should be here. We have 3 1s, which should be here and here and here. And we have 5 2s. And we have 0 4s, and so on. But if you put the density attribute equal to true, then you get the probability instead. So how many zeros are there in your data? Well, it's between it's between 2.5% and 5%. So it's about here. So that's it for plotting. Now you can go on and do some plotting with your data. And as always, this is probably just your first step. You will probably make even more elaborate plots like these in the future.